Welcome to the session on statistical distributions, cumulative probabilities. The objectives for this session are to calculate cumulative probabilities for the binomial distribution. For a random variable x, a cumulative probability function gives the sum of all the individual probabilities up to and including the given value of x in the calculation for probability x less than or equal to little x. For the binomial distribution, x distributed binomially n, p, we can find probability x less than or equal to little x using different sources, including calculators or tables, for various values of n and p. Let's first take a look at the binomial tables. An extract from the binomial tables is shown on your screen. Notice we have various values of the parameter p in the top row and various values of n and x in the leftmost column. We're now going to take a look at the example shown on your screen and try and find various values or various probabilities using the binomial table. Pause the video and have a go. Press play when you're ready to view the solutions. So let's have a go at example 1 part A first. Using the extract from the binomial table on your screen, find the probability that x is less than or equal to 3 for the binomial distribution x distributed binomially with n equals 5 and p equals 0.2. So let's solve this. So with reference to our example, we've highlighted the relevant row and the relevant column. We've highlighted the column for p equal to 0.2 and the row for r equals 3 in the section for n equals 5. So let's talk through this section by section or piece by piece. Here's n equals 5 highlighted in the table and in the distribution. Here's r equals 3, again highlighted in both places. And here's p equals 0.2. So from the table, notice at the intersection point, we've highlighted the number, we've made it bold and red, which is intersecting the row and the column. So therefore, from the table, we have that the probability that x is less than or equal to 3 equals 0.99328. And now for part B. Using the extract from the binomial table on your screen, find the probability that x is less than or equal to 2 for the binomial distribution x distributed binomially with n equals 5 and p equals 0.15. So let's solve this. This time, of course, we've highlighted the column for p equal to 0.15 and we've highlighted the row for r equals 2 in the section for n equals 5. So here's n equals 5 in the table and in our distribution. Here's r equals 2. And here's p equal to 0.15. So at the intersection of the row and the column, we have that the probability that x is less than or equal to 2 equals 0.97339. And now let's have a go at example 1c. Using the extract from the binomial table shown on your screen, find the probability that x is less than or equal to 0 for the binomial distribution x distributed binomially with n equals 6 and p equals 0.3. So let's solve this. Again, we've highlighted the relevant column, p equals 0.3, and the relevant row, r equals 0, and section n equals 6. So here's n equals 6 in our question, here's r equals 0, and here's p equals 0.3. So from the table, we have that the probability that x is less than or equal to 0 is 0.11765. We are now going to find binomial cumulative probabilities in Excel. An extract from the binomial tables is given on your screen. These probabilities can also be found in Excel. So, for example, to find the probability that x is less than or equal to 0 for x distributed binomially with n equals 5 and p equals 0.15, we type equals binom.dist, open bracket, r equals 0, positioned here and here, n equals 5, positioned here, and p equals 0.15, positioned here in our formula for Excel. This will give you in Excel a value of 0.443705 in Excel, and this corresponds with the value given in our table, which is of course, as you can see, 0.44371. On your calculator, you may have a binomial distribution function labeled binomial CD. See if you can find probability that x is less than or equal to 0 for x distributed binomially with n equals 5 and p equals 0.15 on your calculator. Let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2 part A first. The random variable x is distributed binomially with n equals 25 and p equals 0.45. Find the probability that x is less than or equal to 9. So let's solve this. Again, in Excel, type equals binom.dist and then open bracket and then plug in the relevant values for this example. So here we have x equals 9, here we have n equals 25, and here we have p equals 0.45. This will give you a value, probability x less than or equal to 9 equals 0.242371 in Excel. See if this value is consistent with your calculator. If your calculator, of course, is able to calculate it. And now let's solve example 2 part B. In the same distribution for x, we're required to find the probability that x is less than 8. So let's solve this. Notice that probability x less than 8 is actually equal to probability x less than or equal to 7 in this example. So in Excel, we need to type equals binom.dist, open bracket, and x equals 7 positioned here and here, n equals 25 positioned here, and p equals 0.45 positioned here. And when we plug this into Excel, we have that the probability that x is less than or equal to 7 equals 0.242371. Again, do check if you can that this value is consistent with the value on your calculator. And finally, for part C, the random variable x again is distributed binomially with n equals 25 and p equals 0.45. Find the probability that x is greater than or equal to 12. So let's solve this. The probability that x is greater than or equal to 12 is equal to 1 minus the probability that x is less than 12, which is equal to 1 minus the probability that x is less than or equal to 11 in this example. So in Excel, we need to type equals binom.dist, little x equals 11, positioned here and here, n equals 25, positioned here, and p equals 0.45, positioned here. And of course, we have the commas separating all these values. And this gives us 1 minus 0.54257, where of course this decimal value is the probability that x is less than or equal to 11. And this equals 0.45743. It is crucial, as you can see from the previous example, when answering probability questions to interpret phrases correctly. Let's take a look at a few examples. So, if we say no more than 5, we're actually saying x less than or equal to 5. And the calculation we'll be doing is probability x less than or equal to 5. If we have fewer than 6, we mean x less than 6. And again, the relevant calculation is, of course, probability x less than or equal to 5. If we say at most 5, this again means x less than or equal to 5. So the relevant calculation again is the same as shown. If we say at least 10, we're saying x greater than or equal to 10. And the relevant calculation is 1 minus the probability that x is less than or equal to 9. And greater than 9 is x greater than 9. And again, the relevant calculation is 1 minus the probability that x is less than or equal to 9. So far, in Excel and from our tables, we've looked for the probability that x is less than or equal to a little x for our variable capital X distributed binomially with certain parameters. And as you can see, that formula is on your screen, which we would type in Excel. We are now going to look at something slightly different. This time in Excel, we're going to try and find the smallest r value with probability x greater than or equal to little r, less than a given value of alpha for x distributed binomially with parameters n and p. And for this we will type the formula given on your screen, equals binom.inv open bracket np 1 minus alpha close bracket, and then add 1. So let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example part A first. The probability that a spinner lands on blue is 0.2. A player has 14 spins. we are required to find the probability that the player obtains fewer than 2 blues. So this is similar to the previous exercises we've looked at, and we're going to use the same formula in Excel again, or if you've been using your calculator, do practice on your calculator. So let's solve this. We set up the problem first, so let x equal the number of blues in 14 spins. Therefore x is distributed binomially with n equal to 14 as shown here, and p equal to 0.2 as shown here. So therefore in Excel we type equals binom.dist, open bracket, x equal to 2 positioned here and here, n equal to 14, and p equal to 0.2, with commas separating the figures. And so from Excel we obtain that the probability of x less than or equal to 2 is 0.44805. And now for part B. We are required to find the probability that the player obtains more than 3 blues. So let's solve this. Let x equal the number of blues in 14 spins as before, and we have that x is distributed binomially with n equal to 14 and p equal to 0.2. We're looking for the probability that x is greater than 3. This is equal to 1 minus the probability that x is less than or equal to 3. So in Excel we need to type equals binom.dist with x equal to 3 positioned here and here, n equals 14 positioned here, and p equal to 0.2 positioned here, and commas separating the figures. And so from Excel we obtain that the probability of x less than or equal to 3 is equal to 0.69819. And therefore we have that the probability of x greater than 3 equals 1 minus 0.69819. And this equals 0.30181. And now for part C. The school wants to use the spinner in a competition at the school fair. However, the head teacher wants the probability of winning a prize to be less than 0.1. If each player has 14 spins, find the number of blues needed to win a prize. So now in Excel we're going to use the formula equals binom.inv in order to find the smallest value of r, which is going to satisfy the required property. So let's solve this. Again, we let x equal the number of blues in 14 spins. And of course, x is distributed binomially with n is 14 and p is 0.2. We also let r equal the smallest number of blues needed to win a prize. And therefore, from the requirements of the head teacher, we have that we need the probability that x is greater than or equal to r must be less than 0.1. And so we plug in the relevant values. Equals binom.inv, open bracket, n equals 14, p equals 0.2, and 1 minus alpha equals 0.9. When we type this into Excel, we obtain 5. So therefore, r is equal to 5 plus 1, which is 6. Therefore, 6 or more blues will win a prize. This brings us to the end of this session. If you have understood its contents, you should be able to calculate cumulative probabilities for the binomial distribution. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.